Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about a specific problem of how you can arrange n subjects in a circle. Now, this is going to be slightly different than what you have seen in the previous video. And before we talk about the problem of arranging, in this case, you have 6 persons and you want to arrange them sitting on a chair in a circle. Now, before we talk about this problem, we are going to look at a slightly simple problem of how you can arrange 3 persons. Okay, so we're going to try and approach this problem by looking at a simpler case. For example, if you have 3 persons, how can you arrange them if they were to be seated in a straight line? Okay, we're going to look at this case, straight line. And how can you arrange these 3 persons if they are to be seated in a circle? So, seated in a circle, yeah. Now, if we talk about arranging 3 persons in a straight line, this will be applying the same idea which you have seen in the previous example. So we are just going to apply the formula of n factorial. So you have 3 persons and you are going to arrange these 3 persons. They are distinctively different from each other. So you can apply n factorial and the number of ways. So the number of ways that you can arrange 3 persons sitting on a straight line. So you can imagine this is the position of the first person, second and third. So the number of ways is going to be n factorial, and this is going to be 3 factorial, which is equal to 3 times 2 times 1. So you will have 6 different ways of arranging this person. Of course, another way of looking at it, you can apply the idea of basic counting rule. For example, you can think of this as the first step. So the first step is to choose which person to be seated here. And because this is the first stage and you have 3 persons available, therefore the number of options that you have is going to be equal to 3 at this stage. Okay. Now, at the second step or second stage, so this is at the second step, you're going to choose the person that is going to be seated here. And since this space is already filled up, so you have 2 options left. So here we've got 2 options left. And then finally, here is at the last step, which is the third step. And you are going to just choose 1 person. So there's only 1 person left because this space is already being filled up. This is already being filled up. So you only have 1 option left. And according to the idea of basic counting rule, what you can do is you can just multiply this number with this one and with this one, and you will get 6 ways of arranging 3 persons to be seated on a straight line. So there are 2 ways of approaching this problem. You can either think about it using the basic counting rule, or you can just, straightforward apply this formula, which is n factorial. All right, now let us try and perhaps visualize the type of arrangement that you might have with 3 persons sitting on a straight line. Okay, so let's talk about possible arrangement. So here we may have A, B, and C, yeah, and then we can maintain the position of A over here, but we switch the positions for C and B. So there is another arrangement sitting on a straight line. Then we are going to move A to the middle. So here we've got B, A in the middle, and C at the end. and we can also maintain A in the middle, and we just switch the position for C and B. So that is another possible arrangement to sit in a straight line. Yes. And finally, we're going to put person A at the end of this line, and here we've got B and C, and we will maintain A at this end, and we're going to switch the position of C and B. So there you go, we've got ourselves 6 different ways of arranging 3 persons to sit on a straight line. So let us try to imagine this scenario, but it's going to be slightly different because now these people are going to be seated in a circle. Okay, let us try to visualize how can we arrange this person or 3 of them in a circle. Yes. So here we have the possibility of having, for example, here we've got 3 people. So this is in the circle. So perhaps this is A, this is B, this is C. Next, what we can do is we can maintain the position of A, and we switch C and B. Yes. What else that we can do? So what happens if we change the position of A to here? Well, we can see that if we do that, so this one and this one, so here is A, and this is B, this is C. Yes. And then we can have another arrangement where B is on this side and C on the other side. So we're just going to maintain the position of A. So this is A, and this is B, and this is C. Okay, so far so good. Okay, how about we move A to this position then? So we're just following the same line of thought as what we have done here on the straight line. So maybe this is A, and then maybe this is B and C. Next, we're going to maintain A at this same position here, but we're going to switch C and B, B and C. Yeah, so here we've got C and B. So this is something that usually most of students will think how 3 persons can be arranged in a circle. Now, something wrong with this diagram is that, okay, I'm just going to show you what is wrong with this diagram, is the fact that, for example, here we've got person A. So on this side, so on this side is B, and on this side is also is C. Yeah, so this position here is actually the same thing with this position. So on this side is B, and on this side of A is C. It's just that we're just moving the whole bunch of them in this direction. Yeah, so that's why A is now from this position to that position, but actually they are the same thing. Okay, they are the same thing, the same combination of people sitting together, because what they have is actually A in the middle, to this side is B, and to this side is C. The same thing with this one, A is in the middle, to this side of A is B, and to this side of this one is C. So the arrangement here is similar. Yes. The same thing with this one. So here we've got A. Okay, so that means from this position, A is just moving to this position here. But here we've got the same idea. B is on this side, and here we've got C. So here the same idea of arrangement where you have A in the middle, A in the middle, and this side, okay, which is similar to this one, this side is B, and on this side is actually C. Therefore, what I'm trying to say is that the whole thing here is has the same arrangement, which is B, A, C. So this is only one arrangement. Okay, they are not different. Now, following the same argument that I have shown you just now, you can see that for this one, to this side is C and to this side is B. So the arrangement is actually C and A in the middle, and B is on that side, on that side here, towards this side, yes. So for the second figure here, you can see that it is the same arrangement. It is the same arrangement where you have A in the middle, C is this one, and B is that side. Yeah, follow the arrow, so this is CAB. So the same thing with this one. A is at this position where C is this one. Okay, we're going towards this direction, and this is B. Yeah, so we've got C, A, B. Therefore, the whole thing here is the same arrangement, where the arrangement is C, A, and B. I hope you can see the difference between this problem where 3% is to be seated in a straight line, and this one where 3% are to be seated in a circle. When people are sitting on a straight line, you will see that the first person here is going to be a different person than the one sitting at the end. So you can have different possible combination. However, if a person is if those people are to be seated in a circle, the first person at the beginning is also the last person at the end of a circle. And because of that, since people sitting on a straight line is given by this formula and factorial, therefore in the case of people sitting in a circle, the formula to find the number of arrangement is going to be n minus 1 factorial, due to the fact that you will have the same person that will be sitting at the beginning and also at the end. Okay, so that's the idea. And well, we go back to the list of formula here. So this specific formula here can be used in a direct manner in order to solve a problem of arranging n subjects in a circle. Okay, right. Now if we go back to this original problem, now the reason why I give you a different example, slightly different example, is because if we have 3 persons to illustrate the same problem, it is going to be slightly easy for us to visualize the process and to perhaps make you understand why it is as such. Yeah, so that's why I started with a simple problem of having 3 persons to be seated in a circle. So once we have understood why this requires the above formula here, n minus 1, then we can go on and tackle a slightly complicated problem, which is this one. How can you arrange 6 persons in a circle? And this is going to be applying a straightforward formula, which is n minus 1 factorial. So we've got 6 minus 1 is 5 factorial. So 5, 4, 3, 2, 1, 20, 60, 120. So there will be 120 ways of arranging 6 persons to be seated in a circle. Alright, I think that's all for now. Thank you very much for watching.